Simultaneous DDoS attacks that targeted major U.S. websites occurred starting from July 4, 2009. The same happened from July 7 to 10, 2009, which targeted major websites in Korea and overseas. Attack traffics were found in approximately 115,000 IP addresses, hurting a total of 36 websites, including 22 Korean and 14 foreign websites. The attack has caused massive social impact as it mostly attacked government, public, financial institutions, and portal websites. 7.7. The attack, called 7.7 DDoS attack, was a crucial security incident that once again imprinted the social importance of network security. The government and private sector thus had an increased interest in network security, and the incident became a crucial turning point of strengthening preventive and responsive actions at the national level. As we could once again see the importance of network security through previous cases, we will take a look at firewalls, one of the elements of networks to protect the internal network from the external world. Firewalls refer to security policies as well as hardware and software used in supporting such security policies, used for protecting internal information assets from illegal external intrusions and to block the illegal inflow of information. The most important function of firewalls is to access control function for allowing or blocking packets flowing into the internal network or packets connecting to the external network. Firewalls also have a function to check whether the connecting host has been authorized. This check uses various methods of authentication, such as authentication message, user authentication, client authentication, etc. The access information of all packets that pass the firewall are recorded and can be used for inspection when a problem occurs. Firewalls can also solve the problem of not having enough public IP addresses by converting the private IPs of the internal network into public IPs. At the same time, it can also strengthen security for the internal network. The types of firewalls include packet filtering firewalls, stateful inspection firewalls, application gateway firewalls, hybrid firewalls, etc. The packet filtering firewall operates in 3-4 layers and implements investigation in units of packets. The processing speed is fast compared to other firewalls, but its con is that it is unable to provide strong logging and user authentication functions. The stateful inspection firewall operates between 5 to 7 layers and implements investigation in units of sessions. As it is a general gateway and not an exclusive gateway, it can process all services, but there are protocols that it cannot support. The application gateway firewall operates in 7 layers. In other words, it is a firewall that implements investigation and application layers with excellent security, providing strong logging and user authentication functions. However, it has a slow speed. The hybrid firewall is a mixed function of packet filtering and application gateway with excellent security and performance compared to other structures. Also, it has a fast speed. Let's now take a look at the types of firewalls depending on the implementation method. The first is the screening router method, which is located on the border between the internal and external network. It uses a router that operates by analyzing the packet in 3-4 layers. The second is the bastion host method. Here, the firewall software is installed with a host that acts as a gateway placed between the internal and the external network. Because it is located in the interface of the internal and external network, the bastion host can be the primary target of attack. The third type is the dual-homed gateway method. Using a bastion host that has 2 network interface cards, NIC, the routing structure is removed by physically separating the network from the corresponding bastion host. The fourth is the screened host gateway, consisting of a mix of screening router and bastion host. The first defense occurs according to the packet filtering rules at the screening router. For the traffic that passed the screening router, there is a second check that reviews the incoming network traffic from the bastion host. The last is the safest method, the screened subnet. This method is known as the safest type of building firewalls, as it makes a DMZ, a safety zone that observes traffic between internal and external networks, by creating a separate subnet between the screening routers connected to the external and internal networks. Servers that don't mind being open to the public, such as mail servers, DNS servers, etc., can be placed in the DMZ. However, it is desirable that unnecessary log information are not left behind. Now, let's take a look at the intrusion detection system. This is a response system that detects external intrusions of misuses of network resources, data damage, and service disablement. Let's take a closer look. When the system detects an external intrusion, it notifies the administrator via alerts, email, SNMP traps, etc. There is also the shunning function, which commands the system to block the corresponding packet for the attacker or suspicious host's source IP address and service port. It has a function to execute a specific user program depending on the predetermined event. The intrusion detection system can be divided into network-based IDS and host-based IDS, depending on the subject of intrusion detection, and into misuse and anomaly, depending on the method of intrusion detection. Network-based IDS detects intrusion by analyzing the network packets. As this type is installed in a separate host for detection, network intrusion is detected in real time, but it has difficulties in detecting intrusions like the Trojan horse. A host-based IDS detects intrusions through log analysis and process monitoring. Also, it does not need a separate host, as it is installed in the existing server. It cannot detect attacks in real time, but it can detect Trojan horses, etc. A misuse detection is a type where the system judges an intrusion by defining the intrusion features by signatures and matching the patterns. Because this method cannot detect new types of intrusions, there is a need for constant signature updates. An anomaly detection is a type where the system makes judgments based on statistics of various abnormal intrusion behavior. It can respond to unknown attack, which is why it may mistake a normal behavior as an attack. Methods of installing intrusion detection systems include installation in the DMZ area, in the internal network area, or in front of the firewalls. The purpose of installation in the DMZ area is to install the IDS to detect illegal intrusions for services permitted in the firewall. The purpose of installation in the internal network area is to detect illegal intrusions in the internal network by the user who has the permission to connect to the internal network in the firewall. Also, installation in front of firewalls is for detecting intrusion in not only the DMZ area, but also the internal network, where the internal user is unable to detect illegal intrusions in the DMZ area. Next, we will learn about virtual private networks, also known as VPN. In public networks, such as the Internet, the VPN provides a service similar to private networks that use tunneling and encryption techniques. Although the cost of leased lines are high, VPN is used as a network security technique to achieve strong security purposes. Among the types of VPNs, the first is the IPsec VPN, which is a method of implementing a VPN using IPsec protocols. It is the base technology for exclusive VPN devices, and is in fact used as standard technology. It provides a high level of security maintenance, but requires high initial costs for introducing VPN devices. Next are SSL VPNs. SSL VPNs are configured based on SSL protocols that operate between 4 to 7 layers. It can be implemented with a simple web browser and without a need for a client or separate device. However, it is recommended to use a separate SSL accelerator because SSL itself can generate load. Other types of VPNs are the MPLS VPN, which uses a 2-layer high-speed packet switching technology, MPLS protocol, and the mobile VPN, which is for implementing a security network in a mobile environment. Next are the IPsec protocols, which enable structural defects of the TCP/IP protocol to be overcome. It is a protocol developed to standardize security services provided at the IP protocol level and to support the authentication and encryption at the network layer. The IPsec protocol is optional in the IP version 4 environment, but is mandatory in the IP version 6 environment. The IPsec protocol consists of AH, ESP, and IKE protocols. The AH provides authentication and integrity for IP packet data, non-repudiation, and selective prevention of resending. Confidentiality is provided through ESP and may optionally include services provided by AH. Also, IKE provides security negotiation process, key exchange, and management functions. The IPsec protocol security mode can be divided into transport mode and tunnel mode. First, the transport mode provides security services in the upper network layer where the security mechanism is applied to the end host. The tunnel mode provides security services to the entire IP packet where the security mechanism is applied to the security gateway. Also, there are 2 headers, the AH header and ESP header. Each of the headers can operate depending on whether it is in the transport mode or tunnel mode. Also, the header structure changes according to the mode selected. We will now learn about the network attack techniques and response measures. First, the following are the types of network-based attack techniques. Please click on each type. Scanning is an attack used at the preparation stage to find out the relevant vulnerabilities by checking the condition of the service or services used in the system. Scanning can be classified into general sweep, port scan, stealth scan, etc. Sniffing is an attack to outflow important information, such as ID or password, by collecting packets that are sent without encryption on the network and recombining them in order. Switch jamming, ARP redirect, and ICMP redirect are some examples of the sniffing attack technique. Spoofing is an attack of counterfeiting and falsifying crucial information needed for network communication that particularly involves a counterfeiting source IP or a destination IP. Some examples are ARP spoofing, which counterfeits MAC addresses for IP addresses, and DNS spoofing, which counterfeits IPs for domain names. A denial of service attack interrupts regular service by distributing the system resource. In other words, it is an attack that interrupts or disables regular service by attacking system resources or generating overhead in the network. Examples are bandwidth attack, resource depletion attack, program error attack, router and DNS attack, and mixed attacks. As you may all know, a DDoS attack is a type of service attack that intrudes the availability of the network. However, it is a somewhat intelligent attack where the attacker uses a handler or multiple servers, called the command server, to control zombie PCs infected by a malware. The zombie PCs attack a single target at once through the command of the CNC server. There are various ways to defend such DDoS attacks, but today we will take a look at only 4 of them. The first is to block websites that spread malware. It is a response measure to strengthen the degree of security to ensure that websites are not misused for spreading malware and to limit the connection to malware-spreading websites. The second method is to block the command and control server. This is a method for detecting and neutralizing the command and control server or the CNC server, as well as to ensure connection to safe domains by using a security DNS service. The fourth is to block the infected zombie PC from the network. You can strengthen the security for the user PC, detect the infected PCs, and block attacks. The last is to operate a DDoS shelter. By making the attack traffic headed toward the target website bypass to the shelter, general users can use the website as usual. It is desirable for significant institutions or important websites to operate the DDoS shelter, which blocks the attacker from connecting. DDoS attacks are evolving from network bandwidth attacks to application attacks. Therefore, we need specialized response to each type of attack. The UDP ICMP traffic flooding attack sends massive amounts of UDP ICMP packets to the server and packs the network bandwidth that the server has, which then interrupts the connection of the other clients. As a response measure, you can block the inflow of UDP ICMP traffic that is higher than the critical point by setting the PPS value lower than the critical point compared to the inbound packet. The SYN flooding attack delivers massive SYN packets to the server and packs the backlog queue of the server, thereby making the system ignore connection requests from new clients. This type of attack can be responded by blocking the SYN flooding based on the critical point in the firewall, or by dropping the first SYN to check if the second request for packets arrive, thereby determining whether it is spoofing or not. If it is, block it. A get flooding attack is one where the attacker makes repetitive requests for the same URL and makes the web server use its server resources when replying to the client with a corresponding URL data. You can block such attacks by placing limitations on the method of request, by setting the critical point for the number of requests that can be made for each IP, or set a critical point for connecting to the website URL for each time range. A TCP session attack is one where the attack triggers an excessive three-way handshaking process, thereby inducing a service overload. As a response measure, you may set the system to disconnect when there is no movement in data signals between the client and the web server throughout the arranged period for the connection timeout. The slow HTTP post attack is the one where the attacker uses the HTTP post commander to split-send massive amounts of data over a long period to the server, which makes the server consume its available capacity by keeping the server connected for a long time, thus interrupting regular service of other clients. In response to such attacks, you may set the maximum value for the number of concurrent connections available to a certain IP source.